Okay, Assalamualaikum warahmatullahi. My name is Anas Nashuha bin Misran. Okay, I will present about the introduction of magnetic machine. So first, machine is device. This mechanical structure that use power to apply force and control movement to perform an intelligent action. Also, machine can driven by animal and people by natural force such as wind and water, and chemical, thermal or electrical power. So I will tell you about theory of power transmission. Frictional power transmission from pulley to the fitting flat elastic belt is studied. So the Euler's formula proved to be inconsistent with the test data. So we are going to problem statement, which is we studied at important factor that may affect generating companies' profit through wholesale electricity, trading generating capabilities, type of generator owned, fuel cost, transmission loss, and cost of operating system. We will be able to determine which type of transmission, motor power, and reduction ratio to be chosen. We also to be able to analysis and select a proper transmission system and design to install at the equipment.
The objectives of our project is to find the suitable transmission types, the motor power and the reduction ratio for the equipment. Secondly is to identify the best temperature and the relevant space constraint for the transmission system. Other than that is to calculate the applicable output power needed for the transmission system. Lastly is to estimate the installation and maintenance costs for the transmission system and to determine the proper engineering solution to solve the problem. Thank you.
Assalamualaikum and hi, I am Ahmad Wafri bin Ahmad Wardi. So for the design specification, design selections. For the design selections, okay, the design selection is based on the problems and also the objective that we have stated. So it is compulsory to design a system which follows all the needed things. There are three things that we need to consider in this design, which is the type of transmission system, second is the gear ratio we use, and the third is the power needed to supply to the main motor, to the main power source. There are a few parameters that we need to follow. First is the torque of the output torque of the system must be 1000 Nm. It also needed to produce 30 RPM. And lastly, the diameter of the body mill is 2000 mm. We chose a two-stage transmission system. The design shows that it uses a motor connected to a gearbox, which connects to a gear system, which is the smaller and the bigger gear that is connected to the milling cylinder. With the design, it is vital to list all the technical specification of the system, such as the inner radius of mill, cylindrical body, the density of the material, the inertia of gearbox, the friction torque of motor, angular acceleration of mill cylindrical body, and lastly, the efficiency for the gearbox and the gear pair. So for this design, the group decided to choose 0.6 for the value of the gearbox ratio and 0.8 for the value of connecting gear ratio. We need to find the power transmitted to the motor, so we need to make some calculations. So in this system, it is based on the torque mechanism. So the most important formula that we need to use is the Tm equals to T1 plus T2 plus T3. T1 is based on the torque from the acceleration, T2 is based on the torque from the inertia, and T3 is based on the torque from the friction. First is T1. T1 we can find by using the formula shown. Okay, so each of the value have been decided except the value of I. So we need to find the value of I first, I of the mill, inertia of the mill. Okay, so from the calculations we can show that the inertia of the mill is 35,936.68 kilogram meter cube. With the value that we had find, we can show that the value for T1 is equal to 4,308.022 Newton meter. Second is T2. T2 is based on the inertia mass of the system. So using the given formula, we can simply find the value for T2, which is 592.593 Newton meters. And lastly, for T3, we can find it from based on the torque friction from the system that have been stated. So the value of the T3 is 641.519 Newton meters. Using all the combinations from torque, we can find the torque motor of the system is 5,542.134 Newton meters. We can use the equation of P in equals to torque motor times by the angular velocity of the motor. Using the degree ratio and the value of 30 RPM of N2, we can find from the formula the value of N1 is equal to 62.5 RPM. Power in for the system is 36,273.267 watt, or we can simplify by saying it as 36.27 kilowatts. For defining the efficiency of the system, we can use the efficiency calculation, which is P out divided by P in. Based on the value, we can get the efficiency of the system is 0.09.
Okay, hi everyone. So let me introduce myself. I'm BBJan CD1S0177. So for my part is discussions. So we actually need to choose the best transmission type, motor power and reduction ratio. We have to design and select a proper transmission system to be installed at this in this our equipment. And the power torque required at the mill cylindrical body is, the outer diameter is 2000 mm, and the mill rotational output need to be running at 30 RPM. Okay, so basically we have to do the first calculation, which is the total torque motor, and then we have to calculate the T1, T2 and T3, and then the power in is 36,273 and the power out is 33,141 watt. Besides that, the transmission type A two-stage transmission have been chosen for this rotational ball mill system. They have two reasons behind the type was specifically used. First is the transmission type that can offer a better and a bigger value of torque to the system. And then the torque is very important is because of it carry out the heavy duty work or a system that is involving massive load and its functions. For a rotational ball is a mixing process that is being carried on by the machine use a lot of different type materials, with each of them consists of dozens of tons in the process. With a high torque, the system can manage rotate and mixing without any huge constraints. Therefore, with the value of gear ratio is 0.6 at the gearbox and 0.8 at the ball mill, the process and integrations of the gear will be very successful, and the efficiency shows that it doesn't hit the target of 0.9. Although the value of this design indicate to a very low value, which is 0.09, the process can be carried out without the constraint or problems such as not enough speed, low torque produced, or material inside the mill cannot be mixed. So for the conclusion is we use gear system but not using the bell system is to avoid the slip and creep because of the frictions and local working temperature. Using a gearbox is to decrease the space consumptions better than using the bell because bell use more space and the space constraint can be followed by increase the torque of the system for the better mechanical processes. Type of mill we use steel with a high power motor use because cost of installation higher but the decreased risk of a failure and also decreased cost of maintenance. Furthermore, low technology is used but more effective better understanding for the operator.
Hi, my name is Gan Chikyo and my matrix number is 8180215. Okay, me again, I'm Gan Chikyo. So I'm now to make a conclusion for our project. Throughout this project, we finally managed to come out with a design with respect to some objective and carry out the analysis successfully. So in addition, two-step transmission style was chosen for this rotation ball mine system because the transmission style can be offer the better and the bigger volume for Tokyo to the system. So for the rotation ball mine, the machine used a lot of different type material to carry on the mixing process. Each of them consist of dozen of toy in the process. So with a higher force, the system can be managed, rotate and mixing without any huge problem. So in order to improve our design, some recommendation can be considered. First, consider the Tokyo analysis to get a 3D and value system of the machine. So next, we also can apply a suitable SI unit in design the machine so that it will be suitable for practice in our real life application. This is all for our project. Thank you.